few sessions left today, I guess, right? So 30 minutes. So so I'm a director of engineering at Capital One. Excited to show you what we at Capital One do with machine learning. And would like to actually talk about a particular use case that we have. It's called SecondLook, and it's a real-time data processing use case, and shows you how we can trying to disrupt, financial industry. So I work for the credit card line of business, and so involved in building experiences with the, for Capital One customers who do have the Capital One credit card. The work I'm going to show you is actually done by multiple teams in Capital One, involving engineers and the data scientists and the business partners that we have. So many of you probably know Capital One as a bank. It's one of the largest in the United States, with over 65 million accounts. It's 8th largest bank in the US based on the deposits, and fourth largest credit card issuer. Those are the data from the end of 2017. If you have the Capital One credit card, you probably should be receiving regularly what we call a SecondLook alert notifications. Do you want to raise a hand if you do have credit card from Capital One? I guess, all right. So if you don't, I guess my question to you is, what's in your wallet, right? That's the famous phrase that Capital One uses in its commercials. Few of you probably know Capital One as a very innovative technology company, very ambitious and aggressive in disrupting the financial industry domain. We challenge ourselves to build very fast, real-time digital experiences for our customers. And it's a very large organization. Capital One data comes from many, many different lines of businesses, from small business, credit cards, banking, auto loans, and others. In order for us to manage that data and provide real-time experiences to our customers, we have to have a very clear understanding what the data is, where it's coming from, how clean it is, and so we can give a quick access to our engineers and business analysts to develop the applications. We have over 900 agile teams at Capital One, so it's a pretty challenging task. Okay. So that's why kind of our data strategy and continuous integration of microservices architecture is a critical path for us. Super important for us to have a clean data. That's the path to enable machine learning opportunities. We adapt, live, and breathe our principles of cloud computing, constantly raising the bar with operational excellence, focusing on reuse as part of the main guidelines. So Capital One is open source first philosophy, how we build software at Capital One, and contributed back to open source communities. As you can imagine, as a financial institution, it's critically imperative for us to design applications for resiliency in disaster recovery, as we process millions of transactions every day and have very strict financial industry and government guidelines for security and auditing. So there are dozens of machine learning use cases at Capital One, from fraud to credit line scoring, digital marketing, asset wealth management, customization of the content in real time on the website, and many, many others. So I would like to focus just on the small one, SecondLook. So what is the SecondLook? I'm going to show you very quickly a short video. But the application is actually about to notify the customers very quickly if something goes wrong with the transactions when you swipe the credit card, right? Not many of us look at the credit card statements regularly. And what we're trying to do is actually we try to look at every transaction and notify you as soon as possible if something goes wrong. So let me just very quickly show you a quick video here. I'll say something related to voice.
you.
Yeah.
That'll be $46.39. You just swipe right here.
I think I got charged twice.
Oh my goodness, let me take care of that. Can I just have your credit card?
Sure.
All right, you're all set. I'm so sorry.
Okay, no problem. Thank you.
Okay, let's go.
Here goes your order of fries.
Thank you. No. I am so sorry, sir.
Oh, no need, ma'am. I have it. Here's your check.
Oh, thank you. I'm sorry. He's normally so good at restaurants. Yes, he deserved it.
Our customers make millions of transactions each day. By cutting through the clutter and flagging potential issues, SecondLook has saved customers millions of dollars. But it's also giving them something even more valuable: peace of mind. With the power of real-time big data, we are engaging in personalized conversations with customers, in the moment, when it matters most. We're on their side, looking out for them, and customers are letting us know how much that means. We're thinking of a future where we help customers make the best of their money, so that they can focus on what's really important. Now that's changing banking for good.
All right. I'll shoot back here. So in a nutshell, SecondLook helps the customers to spot potential mistakes, right, and unexpected charges. As video has shown, we work with different types of SecondLook use cases, from free trial, double swipe, generous tip, and many others. The case we're going to look at today is called the double swipe. So basically, Capital One sends you an alert or text message every time we see you potentially being charged twice. Okay. So the SecondLook requirements, we process around 20 million transactions per day. And it is a hybrid platform with streaming and batch data processing. We work with what is called authorizations and posted data. Basically, authorizations is what we can detect in real time. When you go to the store and purchase something, you will see on your charge on your credit card as pending. It means that it has been authorized, and in a few days, that charge will be posted. It actually means that it's verified, right? So for the posted transactions, we process in a batch as data is not available to us in real time. It is very critical for us to send our customers only the true alerts, not false positive alerts, as we call them. Very quickly, I wanted to go over the kind of the high-level architecture of what we have. So when the consumer presents a credit card as a payment for the goods and services, it's only the starting point of the complex series of behind-the-scenes transactions and data transfers that occurs. So when the user swipes the credit card, it goes through the credit card transaction load system and lands in our streaming data platform. We leverage the Apache Kafka for that. After that, our processors pick up the events from the streaming data platform and process it through our chain of Apache Spark controls and fast data processors to eventually send a notification to the user, through our messaging and arbitration system. So total time processing an event is less than 1 second, and then the customer receives the notification right away at the time when they make the purchase. So the SecondLook application uses a whitelist of merchants to detect double swipes in real time at the pre-authorization level. So the problem we're trying to solve is that when the customer goes to the store and when the credit card gets authorized, we don't know whether this charge will be posted as a transaction in a few days or not, right? And the charge that gets posted, those are what we call the real double swipes, and the charge that does not get posted is the failed double swipe. So what we try to do is actually we try to take a pair of transactions and try to determine at the pre-authorization level whether it's a double swipe or not. After that, we see what merchant it came from, and those merchants who posted with the high probability, we put it in the whitelist. Whitelist is a list of merchants who actually do the double swipes. Okay. Originally, when we started this project, the whitelist of merchants was developed as a kind of manual ad hoc manner with the sole objective of minimizing the false alerts. It performed okay, reasonably well in keeping the false alerts to minimum. But however, it captures only 20% of the true alerts, true double swipes. So true double swipe is the one that gets both an authorization and the posted transaction, right? And the false double swipe is when there is an authorization, but there is no posted transaction. So what we decided to do, we decided to prototype and leverage a Spark ML model using the Databricks cluster to update our SecondLook double swipe merchant whitelist, because the merchant whitelist is very critical for us to send the correct notifications to the customer. And the effort basically aims at automating the whitelist generation process and maximizing the number of true double swipe while keeping the false alerts at the minimum, and our threshold on this is a 1%. So in order for us to get the model data, we needed to join auth and posted transactions. And what we've done is so for the binary classification model, we defined two classes, class 1 and class 0. True double swipes is the class 1, or the false double swipes is a class 0 with 90% accuracy and close to 0% of the false positives. When we were looking at each swipe, we looked at the pair of those transactions, and we compare whether it has the same merchant name, whether it has the same transaction amount, same account ID, and whether the transactions are happening within 10 minutes of each other. So this slide shows how we basically combine the auth and post data and split them between the class 1 and class 2 merchants. Now, initially we started with the logistic classifier and gradient boosting machine models to look at the whitelist data. So logistic classifier, simple approach uses a logistic regression to compute the probabilities of being double swipe or not. And if probability of the double swipe is greater than the probability of the not double swipe, then the model classifies a pair of those transactions as being the double swipe. GBM, or the gradient boosting model, basically an algorithm that keeps adding the weak learner, 3 classifiers, with the final result being a weighted additive score across all trees introduced to the model. So the graph that we see here showing the ROC curve, which is the receiver operating characteristic curve. Basically, it's a plot that illustrates the diagnostic ability of a binary classifier as its discrimination threshold is varied. The area that ROC plot is the false positive rate, basically false positive double swipes versus the true positive rate for all probability thresholds, and represents the probability that the model scores a random positive sample, higher than a negative sample. And basically, it's just an overall measure of models' classifying power. An area that you see under the ROC of 50% means the total randomness for 2 options, basically like flipping a coin. So when we started this, our business folks wanted to cap the false positive rate at 5%, and for that threshold level, by tracing the ROC curve, the logistic classifier model will get a positive rate of 21% and GBM model of 25%, as you can see on the picture. We have 2 points here, as you can see, to 2881 and 3487. Those represent the model results at 50% probability threshold, meaning that option 1 gets selected if probability 1 greater than 0.5. So usually, in general, GBM outperforms logistic classifier, but in our case, we only see little improvement. And what it shows to us is actually the data was not rich enough, and there was not too much signal in the data for us to, do better. So we needed to do feature engineering and basically create or develop a score to try to get the better results. We've been using for our analysis the 30 days of training data and filter it, eventually splitting it into two sets of merchant lists. So again, for each merchant we created 0, 1 vector, and there is a class 1, which is the off double swipes that do not appear in post data, and class 1 is the off double swipes that do appear in the post data. And our score is basically a ratio of number of instances true double swipes versus full double swipes, looking at the 30 days back. And then we need to look at those two sets and also intersection of those two sets, as you can see in blue, between the class 1 and class 0. So the circle on the left in the green is when the merchants have a big probability of posting a double swipe, and the circle on the left has a very low probability. An intersection of those two circles is our main interest for us, because that's when we don't, there are those merchants is actually who may post the double swipe or may not post the double swipe. So our approach was we went to generate the list in two different steps. Step one is the list with the 0 false positive, and step 2, the list for the common merchants. Those are the ones that cause the highest jump in the true positives. And we would be running the model and adding the merchant to the common merchant list until we hit the false positive rate threshold. What we also have seen is that, as you can see, is actually that we also found out that adding all class 1 merchant to the 0 false positive whitelist results in a very serious overfitting problem with over 79,000 merchants identified. So we needed to balance the model complexity with the accuracy and find a way to reduce number of class 1 merchants to the most accurate ones. What we started doing is actually we started looking at what we call repeat offenders, those merchants that post double swipes more than once over the past 30 days. And we found out that 75% of the merchants appear only once posting the double swipes. And actually, we don't want those, right? To have just one of the true positive is a very weak argument for us to put merchant on the whitelist. And we really do not want to send customers the false alerts, and we would like to be as precise and accurate as possible. So it did make sense for us to select only the repeat offenders, or how we call them, and that decreased our merchant list dramatically. And in a nutshell, to have a very robust models, we need to have this very minimal overfitting. As I mentioned before, so our second step was to look at the common merchants list. That's the list of merchants that contributes both to true and false positives. And we needed to select the merchants incrementally, basically in a greedy manner, that improves the positives rate the most while keeping the false positives at check. We kept adding to the list and ranked the merchants according to the ratio of true positives to false positives. We experimented with two different thresholds of the 1% and 2%, and kept it eventually at 1% to make it as precise as possible. So looking at the result of this graph, and the graph we built with the score and the model created, we see that updated whitelist has lower or better level of false positives. Green line is the new model, modified and updated and tuned until it hits our threshold, and the blue model is the one that used the static merchant list we started with. Same applies to the updated whitelist on true positives. It outperforms the original static list. So in a nutshell, we started with the logistic classifier GBM models, but needed to do extra feature engineering and introduce the score or ratio of true double swipes to false double swipes, to improve the model. And our testing has been done on the 90 days of the transactions and showed that, we basically can double the volume of true alerts while keeping false alerts at existing levels around 1%. The model will be eventually rolled into production as a Spark job to periodically learn from the previous transactions and updating the double swipe merchant whitelist, for the SecondLook application. We also have also dramatically improved on the accuracy of the whitelist compared to the static one we had initially. So again, the green line is the improved model, and the blue line is the original whitelist accuracy. And on the next slide, I wanted to show you kind of a summary in a nutshell, the sequence of steps we took and how for this particular use case or other use cases we use as well. So the first one is, step one is usually you have to define the problem. Step two, you prepare your data. We spent a lot of time massaging the data and preparing our data and finding the data that is needed. We identified the outliers. We tried with the data pre-processing, and then we needed to apply the feature engineering to get the better results. Step three is actually, so we went to the spot check and selection of the algorithms, evaluated different machine learning algorithms, choose the right test options when we evaluating the machine learning algorithms, and then we use the data-driven approach when choosing those. Then we worked on improving the results, and then we present the results. We present the results to our business community as well, and we are at the step when we train for final machine learning algorithm and then deploy to production. And at the end of the day, make our customers happy, and the Capital One credit card customers receive our alerts when something goes wrong with their transaction. That's all I wanted to share with you today. So if there are any questions, I'm happy to answer.